Cool. Hey, everyone. My name is Adriel, and I will be talking about my automation side project called Peace. So, what is Peace? Peace is a framework which provides constraints and common functionality such that if you write automation code according to these constraints and plug them into the common functionality, you get a nice tool. Nice is subjective, I know, but we will see an example. And it's written in Rust. That's why it's relevant. Cool. So as with every side project, there's an origin story. And this is the story of Peace. So in my first job, I was assigned a task with my team to fully automate this software deployment process, which was manual, 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 manual. And obviously, the solution is automatic. So we tried to implement this process. Click, wait, done. And we aimed for end-to-end automation, repeatable correctness, and performance. As you will, right? Quite sensible. And if you measure success using these three metrics, it was undeniable. We took deployment time down from 2 weeks to 30 minutes. So yay, right? Except our users, they're like, Azrael, we hate this. We hate this. It doesn't enhance our lives because when we introduced automation, what we really did was we changed the work from I'm doing step 1, 2, 3, which is at my own pace, to let me fill in the parameters, press go, and wait. And after about maybe half an hour, I would get the result, which would be success. That's fine. But if it was a failure, then I would have to figure out what the error means, figure out which step it came from, and what parameters the step what parameters feed into that step. So essentially, if I correct my parameter, I would still have to go through the whole loop of correct it, and might take half a minute, but wait half an hour for the feedback. And that feedback loop being half an hour every time I correct the parameter was frustrating. And for new users, it was especially painful because we're telling them to fill in this lot of parameters which they do not understand that feeds into a process which they cannot see. It's like this box, right? Magic box. And to create an environment which they cannot visualize. And so essentially, they did not know what they were doing, but it was our fault. So we just created pain. Ideally, we would have created something which, while providing the benefits of automation, so 1, 2, and 3, we should not subtract the benefits of manual execution, so 4, 5, and 6. So what we did was we took away understandability, we took away control, and by taking away understandability and control, we inadvertently took away morale, what little they had. Right. So we had to pay this back. So Peace, I want to show you how Peace provides you the benefits of automation and retains the benefits of manual execution through a tool built using Peace called EnvMan, short for Environment Manager. So what EnvMan does is it downloads a file from GitHub. It's a web application. It creates some resources in Amazon, and then it uploads that web app to Amazon. Notably, there's a missing step of launch a server or Lambda and run that web application, but I'm all out of AWS credits. Cool. So for understandability, well, we took it away, so we should put it back. And there are two general ways we tend to write automation. The first is we write automation that produces so little output that we can't tell what's going on. The second way we write automation is we write it and it produces so much output that we still can't tell what's going on. Right, so ideally we have some middle ground. So let's look at a demo. So this is the not enough information variant. Can you tell what's going on? No, right? And I promise something is happening. And likewise, if we clean up, it's also going to show us nothing. Now, if we were to do the same thing, but we had too much information, it would look something like this, where we just can't tell how many steps there are in the process and what's happening. But you can tell something is happening, right? Now let's try something balanced. So in the next execution, see if you can see how many steps there are and if the steps succeeded. Yay. So should be quite clear. There are 6 steps and green means good. Each of those steps worked, right? From fresh eyes, you can understand. And also in the output, there are links to each of the resources that were created. So with no training whatsoever, you can understand the output. And clean is similar. There is a progress bar for each resource or each step. And when things are cleaned up, you know they're cleaned up. It says it doesn't exist. So you don't have that lingering resource in the cloud which you're paying for forever. Yeah. And this is all good for a successful execution, but more interesting is what happens when things go wrong, right? So let's introduce some bad connections into our environment. We have 40 kilobits per second connection speed, very fast. So eventually, we should see an error, but first we have to wait. There is an ETA. Cool. There we go. So it's quite clear which step failed. I mean, yes, it was the last step, but also you can see it's red, right? The red thing is the bad thing. And you don't have to guess. Like if you think about any automation tool you've run, when it fails, right? So over here, we show you what went wrong or which step went wrong, what went wrong, we failed to upload this file, why it went wrong, it timed out, and how to recover. Make sure you're connected to the internet and try again. We are connected, it's just a little bit slow. And without guessing, when it failed, you know which resources were created, and you know which resource that was not created. You don't have to guess. So if we fix our environment, which we will like increase internet speed, I can run deploy again, and you'll see that this tool is clever enough to pick up where it left off. I didn't have to tell it. It knows, 1 through 5, we're done. 6 wasn't done, I'll do that again. Like imagine your users running automation, they're like, run the shell script, run the shell script, run the shell script, and launches like 10 servers, 20 servers, 30 servers. That is more cost than you anticipated. Cool. So we can clean up. And when all is well, we are not paying for things we aren't using. All right. So in summary, for understandability with information, the Goldilocks principle applies. Too much information is overwhelming. Too little information is not useful. And there's a middle ground, which is just right. You can understand without much effort. Curious thing is, the more understanding you have, the more your capacity for information. And Peace tries to fit the most relevant information on one screen. So you don't have to scroll up, you don't have to search for your most relevant information. Cool. So that was putting some understandability back. Now we should give back control. Now with automation, normally we are given one button, start, and that's it, right? We're normally given the button to start or update, create or update our environment, or start the deletion of our environment. But while pressing start itself is it's not difficult. Knowing when to press start, knowing if it's safe to press start is difficult. So before we press start, we should understand three things: where we are, the current state; where we want to go, the goal state; and the difference, which is like the distance between the current and the goal state. Because if we start with nothing and we end up with something, then our distance is something. If we start with something and we end up with something, the distance is nothing. And if we start with something and end up with something else, the distance is the else, right? And when we understand these three things, then we will know, we can make an informed decision whether to press go. Now, when you've pressed go, can you press stop? Without automation, you can, right? Because if I'm doing my work, step 1, 2, 3, and my boss says, Azrael, stop work, I'll be like, gladly. But I've never heard that before. But if you want automation to have a stop button, you need to intentionally code your interruptibility into that execution. So while you can press Control C on a command line tool, because like, oh no, it's I changed my mind, let's stop the process. We're not really concerned about interruptibility on its own. What we want is safe interruptibility. So I press stop, but stop when it is safe to do so. And if you are in, say, a 10-step process, and you remembered, step 7, I've got an incorrect parameter, and execution is currently on step 5, let me interrupt the process, change that parameter, and restart the process. And the automation should pick up where it left off, right? So when I stop the process, don't throw away everything you've done to get to this point. You spent half an hour getting here, and I want to fix the thing after you. So don't like undo the work. It's good. So let's see how all of this works together in Nven. Okay, so let's clear. So before we run our deployment, what is the current state? So just like you can run git status, you can run Nven status. Show me what is. And where are we going? Nven goal will show us the state of the environment that would be if we run the deployment. And this is before we run the deployment. And the difference between where we are and where we should be is end-man diff. So just like git, you have git diff, end-man, you've got end-man diff. We know our file is going to be downloaded. It's going to change from 0 bytes to 6 megs. And all of these resources will be created in Amazon. And once we've understood this, no surprises here, then we can run end-man deploy. But while it is deploying, I will change my mind and interrupt the process. Cool. So ready, steady, go. All right, so you can see the steps that were being executed were continuing to be executed, but there are steps which were not started, which were interrupted. And crucially, you can understand which ones were not started, right? It's like it says, so no guesswork. You can see steps 1 through 3 are done. Step 5 was done. Steps 4 and 6 were not created. And you can see this in the output as well. Instance profile and S3 object, they both do not exist. If we run end-man diff, we can see that 1 through 3 and 5, they are up to date, in sync with the server, or they are created in Amazon. 4 and 6, 6 probably has a bug with the diff code, but 4 and 6, they haven't been created. So the next time I run deploy, they will be created. But let's say I change the parameters to this automation. I will change my web application download from 011 to 012. And if we look at the diff now, you'll see that step 1 will newly have changed to say, I will download this file. It's going to change from 0 bytes to 6 megs. So I know before I run the deployment, step 1, 4, and 6 will change. 2, 3, and 5 will not. No guesswork. It's safe. I will run deploy. Cool. So as expected, 1, 4, 6, done, done, done. The rest, nothing to do. Right. So imagine yourself waking up and you have to go fix an environment. This will give you peace of mind, right? Well, it would give me some peace of mind. Cool. So we can also interrupt when we clean up. So out of the 6 resources, let's say I'm cleaning up and I decide, oh no, I don't want to delete everything. So at this point, we've had our 6-step process. We've gone backwards to only having 2 resources created and the rest of them not created. I could fully clean up, but I also can go the other way and fully deploy from my mental state. So if I deploy from this state, steps 1, 4, 5, and 6 will be deployed again. Steps 2 and 3, we can reuse what was not cleaned up. So if we run deploy, you'll see that's exactly what happens. Cool. And like, why would we want to ever interrupt a cleanup process? Well, imagine you have a customer who says, we don't need this environment anymore. You can clean it up. And we're like, you sure? And they're like, yes. But so we start the cleanup process and they're like, stop, Ezra. And then like, we can't, right? But luckily, in those cases, we have actually preempted some customers going, well, they don't want to pay for the environment anymore, but we know they actually will need something, right? So we just point their environment at a blank server, watch them, well, wait for them to cry. We're like, here's the magic, we'll put it back, right? So that's why you should build a stop button into your automation if you can. And if you use a piece framework, the stop button is built in for you. Cool, so let's clean up for real. Whoop. Clean. Cool. So with control, that's nice actually to be able to control the direction of your deployments, knowing what would happen. But one thing I haven't done with control is running a subset of your process. Because if you have a subset where, let's say you have a process which deploys a server, installs an application, and you didn't really care about the application bit, you're just testing the OS. It would be nice to have the control to iterate over the first half of the process. So decrease your feedback loop. Yeah, so that's an idea, not hard, just haven't implemented it yet. Cool. Onto morale. We've put back some understandability, we've given back some control, but not all users who use automation are like software developers, right? They may not all have a software background, but they still may be using the automation tools. So realistically, we shouldn't expect everyone to use the command line. So what can we do for morale? Yes. So we'll see one shortly. So if you think about understandability, normally when we explain a process or an environment that we create, we tend to draw a diagram on the whiteboard, or we create one and put it into the internal documentation site. But these diagrams, they tend to be inaccurate because you save it, someone changes the environment, and it's out of date, right? Or the other issue with these diagrams is they've got lots of boxes, and they got this tangle of lines, and you're like, oh, this one goes there. Right? So you have to go chase those lines and figure out what it means. So it's not understandable because it isn't clear. So how can we make something clear? Well, we can clear the screen, but let's also throw in a web interface. Cool. So here we have two diagrams. The diagram on the left is the progress diagram, which shows you the process that is being automated. And the diagram on the right is the outcome diagram, which shows you what the environment you are deploying would look like. And this is before you ever deploy the environment. And if we click on these green tags on the right, there's one for each step. The first step is downloading a file. You can see that localhost is sending a request to GitHub, pulling it down to this path. IAM policy, we're creating this in Amazon, then create the IAM role, instance profile, create the S3 bucket, and upload the file to that bucket. And if you ever need to go back to the previous step, you don't have to erase your whiteboard. You can just go, oh, which step was not clear? That one or that one, right? And you can go back and forth, explain the steps and what's happening to your person who's learning. Now, while this is brilliant, I like this one. So what you saw before was a diagram of the example environment, what it would look like if we deployed something. But what's the state of an actual environment? We can discover it. So right now, most of the nodes are semi-invisible, and that's because they don't exist. I cleaned it up before. But if we were to deploy the environment, you can watch the diagram on the left, which is the progress diagram. That shows you which steps are being executed, or you can watch the diagram on the right, which is the outcome diagram. The resources that are involved in the steps that are executing will be animated. Go. So the arrows show what's happening between hosts. So if there's any issues, you would see it. Now, all of the nodes are now visible, meaning they exist. So really important to keep the rendering consistent with the actual thing. Otherwise, if you render something invisible, it's like, oh, I'm not paying for anything, but then you're paying for this menu. All right, so if we clean up, we can also see the nodes disappear. So quite clear, we have created and cleaned up our environment. What happens if we have the error again? Let's do that. Well, and if you're curious, the initial yellow discovery is what is the state of the environment that, what is the actual state of the environment before I deploy it? Because if the user made a decision based on stale states, then we want to protect them from actually changing the environment. So we would stop if the actual state is different to what was cached before. Ready? Go. Cool. So very apparent, the S3 object step failed, and which resources were involved in this failure, the local web app file and the web app tar where it should be written to. So without looking at the error message at all, you can tell where on your system you should probably start looking, right? Saves you lots of investigation time, saves you lots of brain power, sustainable. So I know the error itself is not surfaced on this UI. It's currently written to the server logs, but yeah, these are just print lines. But that's surfacing of that information, not too hard, just needs to be written. And if we fix our connection issue, it will complete as before. Cool. All right, so when we come to talking about morale, a lot of work is put into the aesthetics. So what is the current state? If you wake up in the middle of the night, say you're working on call, I don't want to have to go dig for that thing I know exists in this environment. I know what it is, take me there, right? So don't make me click like 5 times through the web console. So that's why very deliberately, every step, every thing that's created, there's a direct link to that thing. And the web interface just makes it easier to understand the entire environment. So if you can hook this into, say, some monitoring system and go red on the thing that's failing, then you can just see it. You don't have to go look for it. With progress, we reduce the amount of information to something digestible, something more visual. And with errors, instead of panicking, which is the visual equivalent of printing a stack trace, we take the error, refine it, and make it beautiful. Right? Because if you always show what went wrong, why it went wrong, and how to recover, then you're removing or you're helping the person recover from a bad situation. And when you help someone recover from a bad situation, you recover their morale. So that's what peace aims to do, and this is the best effort. Cool. And with all of these aesthetics, that black box is no longer a black box, right? It's no longer opaque. It's completely clear. You can see inside it, you can understand it, and you can control it. So any questions so far? Or shall I move on? Cool. So how does this all work? Magic. So let's take a look at the architecture. Piece is categorized into two main parts: the item definition and the common functionality. And the item definition is the shape of logic and data for anything that is managed by automation. And the common functionality works with these item definitions and provides you the execution and provides you the interruptibility in there and gives you a user interface. So command line or web, etc. Item crates are the implementation of that item definition. So a file download or creating an S3 bucket, each of these are its own item crate, which is the Rust version of a uploadable package. Now, these slides are available online, so if you need them high res, you can. Cool. And the tool is what connects different item implementations together, plugs them into the common functionality, and you give that to your user to run. Cool. So we're going to look at these in detail. So first, we'll look at the item definition. If you think about each step of an automation process as one function to do step 1, do step 2, do step 3, that would be like the apply function. And for an item, we are actually collecting, well, an item is a collection of functions. And we're not only concerned with doing the step, we're also concerned with reading what the current state is, reading what it would be if we run the automation. What's the difference between the current state and the goal state? What's a clean state is as though if I were to undo this automation to nothing, that's the clean state. Apply is to do the work, and interactions is what hosts and paths, like file paths or URLs, are involved in this item's automation. So when it's running, is it doing a pull of data? I send a request and pull something back. Or is it doing a push of data? I'm pushing data to this other server. That's captured in interactions. And that's used for rendering the web interface. Magic, right? So an example of this, the file download, the current state would be tell me if the file exists, and well, if it doesn't exist, it doesn't exist. But if it does exist, also tell me the MD5 hash of the file. The goal state of a file download is whatever the state of the file is on the server I will be downloading from. And we can generally pull out 2 bits of information without downloading the file, which is the content length, number of bytes, and the e tag header. And that's usually the MD5 hash of the file. Can be something else, but usually servers have been responding with MD5 hash. The diff state, or state diff, would be, let's compare the local state and the state returned from the server. If they are the same, we don't need to download the file. If they are different, then we probably do. Clean state is the file doesn't exist. And apply is turn the current state into the goal state if I'm downloading a file, or turn the current state into the clean state if I am cleaning up my environment. And interactions would be localhost is pulling from this server and writing to this path on disk. Right, so that's one collection of functions, which is our item. Now, if we have a collection of items, that's called a flow. So item, 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 that's in a flow, but a flow will also contain the dependencies between the items. So what runs first before the other stuff? We need to download the file and create a bucket before we can upload the file that we downloaded to that bucket. And a bit of technical detail here. In Rust, you cannot store different concrete types in a collection. So we put them on the heap and we store the addresses. So they're all like 64 bits, right? So we hold the addresses, and that's what we call a boxed item. Cool. So commands. When you have your flow, the collection of items, and some parameters, we can run different commands for you. So example is the discover command, which will run the current state or state current and state goal functions, which goes, what's the current state of this thing and the goal state? Let me discover that for all of the items in your process or in your flow and display that to the user. So this is how we show what is before the user goes, I want to change the thing. The diff command takes the two different states, compares them, and shows that to the user. The ensure command says, let's take the current state and turn it into the goal state through the apply function. And that means, that means turn this first thing into the second thing through that, right? And the clean state is take the current state and turn it into the clean state through the apply function as well. So there's a bit of magic here. So besides the iteration through the items, which pretty much a loop and calling the right functions, piece will also pass parameters or pass values between the items. And because each of your items has different types as parameters, that is magic. Yeah, we won't get into that magic yet, not today, but there is documentation how it's done. It's black magic. Cool. So we're going to look at the detail of, one more thing about items. So every item has input, which we call parameters, and output, which we call state. And the input will contain where I fetch my information from, where I'm writing information to, and any other information I need to access these two locations. The output is whether or not the thing I'm managing exists. If it does exist, where does it live? And show me a summary of the contents. So just enough for me to compare this state with another state. I don't need to load the whole thing into memory, because if you have a 10 gig file, well, comparing two 10 gig file states is probably not ideal. So we just need a hash of it, good enough to tell the difference. Now, when you have your flow, which is all of your items, your parameters, which is the values you feed into each item, and you've chosen an output, command line or web or both, you're ready to run a command. And these three things together, parameters, flow, and output, that's known as a command context, which is a bag of stuff you need to run the command with. And we provide some standard commands for you to run. So ensure command is like run the automation. Clean command means delete everything. And you can expose these to your users in your own language. So deploy probably sounds more familiar than ensure. And clean, maybe you want to call delete or remove. And all of that together is your tool. And if you look at the colors, it should be quite apparent that most of the logic doesn't live in the tool. They either live in the piece framework or they live in item crates. And this is deliberately done so that you can share and reuse different items that you write or different people from third parties or community write. So like a file download is a file download. There's no proprietary information in there. What is proprietary would be, I have this URL, it's an internal server, I have these credentials. And those are all fed in through your tool. So there's no IP leakage. And also the connections between items, that's probably also a bit proprietary. So that also lives in your tool. Cool. So all of Piece, well, Piece is my side project. And for Piece to work, there were other side projects to actually make it work. And the first notable one is called Interruptible, and it provides interruptibility. And how it works is if you think about a music file or audio and you play your file, you're streaming bytes from your audio file into a buffer and into a speaker, and out comes music, right? And if you pause that music, then bytes which were already in your buffer will continue to be played out your speaker, but bytes which hadn't reached your buffer, hadn't been read, they will not be fed in and they will not be played. And if you think about automation, to make interruptibility work, we will be streaming not bytes, but we'll be streaming logic. And we don't stream logic to a speaker, that would sound like psst, right? But then if you stream logic to an executor, you will, you will run that logic. And when you hit pause or interrupt, then any logic which had already been streamed and is running, we continue to execute until it's completed. And if we, if we stop the execution, any logic that was not started, we don't start it. Which means at the end of the entire execution, any part of your environment which had no logic executed against it, the state at the end is the state at the beginning. And the part of your environment where you had logic run against it, the state at the end is the state that was produced after the execution. So we combine these two, the modified states plus the initial states, and that's your final state of your environment. And that's what we show the user. And the second side project is called .interactive, or .ix for short. And it's the thing which generates the diagrams for the process as well as the outcome. And how that works is you take an input object, which is a data structure. We have a YAML version as well. We can see that shortly. We generate the SVG using graphviz dot. That's a program which generates graphs. And that's where the dot name came from. And we add some CSS styles using Tailwind. So that's what gives it some interactivity. And little demo of that is here, where the structure on the left is what generates the thing on the right. And if we look at this local host text over here, I would type on the left to say hello, and that's you can see hello appearing on the right. If I search for blue and change that to red, you'll see the diagram changes. And all of the animations are also encoded into this using CSS animations. So we just link the animation code to the node. And in Piece, we feed in this data structure through the programmatic API. So that's how it generates the real-time diagrams. Cool. Now, project status. So is Piece ready to be used? Well, for development workflows and short-lived environments where the environment, its lifespan it's shorter than the lifespan of one version of your tool, then I would say you can use Piece for that. I would use it. But for production workflows or environments which are meant to be stable and they span multiple versions of your tool, do not use Piece because you will not have Piece. And main reason for that is the API and data stability. I want to move some code around that will break any code that's using those. And I do store some states on disk, and those paths will change a little bit as well. So that's why it's not stable in terms of data. Cool. Some links to the project. So piece.mk for the project website, piece.mk/book for these slides, and it's on GitHub as well. And just to end, I'd like to leave you with this note. So to engineer with empathy, whether it's verbal, visual, or vocal, refine your voice, connect, and communicate with clarity. Thank you very much for listening, and I'm happy to take questions.